All right, so today I want to talk about Ksp for chemistry, and this is your um, solubility product for K, and it's going to look a lot like what we've been doing for Kc. Um, but I'm just going to take this silver chloride example that they had. That silver chloride, they would tell us in the books, is a solid. It's insoluble. But really, if we look at a forward and reverse reaction, really what's going on is we have some aluminum plus, and we have some chlorine minus floating around in that solution, but when we look at our equilibrium, the equilibrium is over here. And so this is why we would call it insoluble. So to get our Ksp, just like when we did Kp or Kc, you take the product concentration of the products over the concentration of reactants, but in everything for solubility, the reactant is always going to be solid, and we don't take those into account for concentration. So therefore, it's always just the concentration of your products on the top. And so that's all we really need to know to calculate. Also, if you have subscripts or whatever, you just put the square there. If that's what you need to do, it doesn't fit in here. But that's kind of how to calculate Ksp, and then if you calculate a Qc value and then you plot it on your thing, whichever one it goes to, if it's forward or reverse, that'll tell you that. So if I had my K value here and my Q value here, well, I'm going to know that I have a solid and I need to get back to equilibrium and whatnot. So there you go. That's kind of how to calculate Ksp. It's really similar to Kp, but this one just deals with solubility. Also, we can find using these Ksp values. The smaller one means it needs a lower concentration, and so if I have two things that could form, which one's going to form a solid first, you can do those comparisons as well. An example of that would be copper iodide or lead iodide, PbI2 if this is 2 plus, because iodide's 1 minus, Cu 1 plus, 1 minus. And then we're hunky-dory. But if I have these copper and these iodide molecules, and I have copper and lead in there, and I add iodide, which one's going to precipitate first? Well, we don't know. Well, if we know that the Ksp of the copper is 2 times 10 to the negative 6, and this Ksp is, and I'm making up these values, of the PbI is 4 times 10 to the negative 4th. Well, because the copper one is smaller, that means this concentration, because remember where this number comes from, that this concentration can be lower, and we're still going to get a solid, so this one would precipitate first. So that is also how Ksp can be used, but that's just a look at Ksp for chemistry. I hope that was helpful.